Hi, and welcome to a Popetti Math YouTube video tutorial in Algebra 1. This video is Chapter 10, Lesson 6, Quadratic Word Problems, Exercise number 6, found in the workbook. But if you're here just for the tutorial part and you don't have the workbook, that's awesome too. It's great to have you here. All right, so our last question in this lesson says, the length of a rectangular pool is 4 meters less than twice the width. A walkway 1 meter wide is to be installed around the entire pool. Find the dimensions of the pool if the combined area of the pool and the walkway is 56 square meters. So the first thing that we want to do is let's draw a picture to represent this pool. So we have a rectangular pool, and we know that the length is 4 meters less than twice the width. So we could set up an equation to represent our length and our width here. So if we want to let W equal our width of the pool, we know that our length is 4 meters less than twice the width. So 4 meters less than twice the width would be 2W minus 4. And that would be our length. Now, it says a walkway 1 meter wide is to be installed around the entire pool. So we're going to now install this walkway, and it's going to go around the entire pool just like that. All right, so let's put in all the information we know into this diagram. So we know that our length is going to be 2W minus 4. We know that our width is going to be W. We also know that this walkway is going to be 1 meter wide here, 1 meter wide here, 1 meter wide here, and 1 meter wide there. So find the dimensions of the pool if the combined area, is 56 square meters. Okay, so let's take a look at our pool has a width of W. But with the walkway, it's really W plus 1 meter here and 1 meter here. So our new width is really W plus 2, because we have the W for the width and then the 2 meters, one on each side. Same thing over here, we have 2W minus 4 for the length, plus 1, 2. So that's 2W minus 4 plus 2 meters. So that's going to actually be 2W minus 2. So we have our new length is 2W minus 2, and our new width is W plus 2. That's the length and width of the pool and the walkway. And we know that the area is 56 square meters. So we know that our area of a rectangle is length times width. We know our area is going to be 56. We know that our length, our new length, is 2W minus 2. And we know that our new width is W plus 2. Now, right here, we have enough information, and with our knowledge of quadratics, we can find the exact length and width of this pool. So let's go ahead and do that. So we're going to double distribute here. So we're going to do 2W times W, and we're going to get 2W squared. We're going to get 2W times 2, and that's going to be 4W. Negative 2 times W will give us negative 2W. And finally, negative 2 times 2 will give us negative 4. All right, we could combine some like terms, and we'll have 56 is equal to 2W squared plus 2W minus 4. And before we could solve any quadratic, the first thing that we have to do is we have to move our terms all to the same side and have our equation equal to 0. Now we're going to have 0 is equal to 2W squared plus 2W minus 60. All right. So again, I'm going to rewrite this over here now underneath the pool. And we have 2W squared plus 2W minus 60 equals 0. And remember in our directions in the beginning of this, if you've been with us since the exercise number 1 video, it said to first try to factor. So let's try to do that. So our first key the thing that we want to do when we factor is we want to make sure that we're looking and seeing if there is a GCF. And you should recognize that there is a GCF in this trinomial right here, because all of these terms are divisible by 2. Awesome. So we're going to factor out a 2. And what's going to be left over is w squared plus w. And 2 times what will give me negative 60? Negative 30. Now this should look familiar and also factorable, because there are definitely two numbers that we've seen many times already that multiply to 30 and can combine to a positive 1. And what are those two numbers? Well, we'll bring down the 2, and we're going to factor here now. And we'll start each one off with w and w. And remember, 5 times 6 is 30. And we could definitely get a positive 1 from a 5 and a 6 if we make the 6 positive and the 5 negative. So yes, this was definitely factorable. And when we solve by factoring, we're going to set each factor equal to 0. The 2, again, does not affect each factor, so we're not going to set the 2 equal to 0. Just the w minus 5 and the w plus 6. Solving over here, we're going to add 5, and we'll get the width is 5. And we'll subtract 6 here, and we'll get that the width is negative 6. But again, you can't have a negative width. And when we deal with length and width dimensions, we can only have positive answers. So we're going to reject this one over here, which leaves us with one answer. The w equals 5. But what does it want us to do in this question? Let's go back and read. Find the dimensions of the pool. So if we know that w equals 5, okay, so let's go to purple now. So our width is 5, so this is 5. But we want to also know our length, so we're going to have to substitute 5 in for w right here to get our length. And 2 times 5 is 10, minus 4 is 6. So our dimensions are that the width is 5, and we're measuring in meters, and our length is 6 meters. Once again, this question had a lot to it. It would probably be most helpful to start off by drawing that diagram. After you draw the diagram, then after that, you have to set up the correct let statements and know the area formula for a rectangle. Then after you finally correctly multiply it out and set it equal to 0 to recognize that it is factorable. You could have used the quadratic formula. That would have worked as well. But yeah, a lot to this problem, but you were able to get through it, hopefully. If this video was helpful in helping you get through this exercise, please give this video a thumbs up. All right. Thank you.